Please. My laptop was a bit slow.
Now let's focus on our next topic in route filtering method, and it's a route map. Wait. Our next topic is PBR, policy-based routing. And for
PBR.
policy-based,
Is PBR
yes,
or
PBR,
PBR?
policy-based routing. And in policy-based routing, we can discuss again route map configuration. Route map configuration. To configure PBR, policy-based routing, route map can help you because I told you route map is a concept. Route map is a command, it's a concept, and route map we are using for multiple purpose. Route map we are using for redistributing route filtering. Remember our OSP of implementation to increase our metric and metric type in OSPF, we can use route map concept, right? Juancy, remember our topic. Remember this discussion? In OSPF, we can change metric type and metric. Hello, Juancy, can you hear me, dear?
Hello, dear.
Juancy, can you hear me now?
Now I can hear you.
Okay. So remember our last topic in OSPF redistribution route? We can change metric type and metric for specific route in OSPF design, right? Remember our previous session? To
Yes,
achieve to achieve this task, we complete our topic how to change metric and metric type in OSPF. Remember OE2, OE1?
yes.
Yes. So to configure this concept, to change metric type and metric in OSPF scenario, we can use the route map command. Route map command. Again, route map
Okay.
command, route map concept you can use in policy-based routing. So this is our topic for today. To configure policy-based routing, we can take a help of route map. And when
Okay.
you will discuss about BGP, when we'll focus on BGP, in BGP we can again use a route map concept. Let's talk about PBR, policy-based routing, and to configure policy-based routing, we can take a help of route map command. So what is our task? What is PBR? What is policy-based routing? Topic is policy-based routing, and PBR we can configure with source base. We can configure with destination base. We can configure with services base, and one more option, it's called packet size. Packet size. So what is PBR? Policy-based routing. Let's talk about scenario first. So I have multiple ISP connection. For example, this is my branch office router. You can see, okay. And I have two
Yes.
ISP connection. I have two ISP connection. This is ISP1 connection, ISP1, and this is my uh, primary connection, you can say, okay. Here we have a speed 100 Mbps. 100 Mbps. I have one more ISP connection in my design. My company is they have multiple ISP connection, ISP1, ISP2, this is ISP2, this is ISP1. Now, this is my backup link, for example. This is my backup link ISP2, backup link. Here we have a speed of approx 50 Mbps. Now, this portion is my LAN side portion. Here we have multiple subnets, you can say multiple computers, you can say. Now,
Mm.
Now I want to utilize both the ISP connection. My point is, this is my primary connection. This is my primary connection. This is my secondary connection, secondary ISP connection,
Mm.
secondary ISP connection. I want to utilize both the routes. I want to utilize both the routes. How? For example, I'm saying if source 192, 168, 10.2, 10.2, 10.3, if these two computers they are trying to access any destination on outside, then
Mm.
traffic will travel via ISP1. And when
Mm.
10.3, 10.4, and 10.5, if these five computers they are trying to access any destination, they can go via ISP2. This is called
Mm.
PBR, policy based routing.
Oh.
Policy based routing with source base, where this router is checking what? Source. If if this source 10.2, 10.3, if they are coming, they can go via ISP1. If 10.3, 4, and 5, if they are coming, they are hitting for any destination, okay, they can go via ISP2. This router can take a decision. Clear my point?
It's like the firewall, right?
It's not a firewall. Here we are trying
But
to balance our
mm.
traffic. We are trying to balance our
Okay.
traffic. Okay, what we are doing, I just want to, for example, these two computers, 10.2 and 10.3. Okay, they are the part of, for example, uh, software team. They are the part of software team. Okay, they want to
Mm.
upload and download big data, so they need good ISP connection. And this team is
Mm.
for example, they are the marketing team. Okay, they want to upload and download only PDF file, Excel file. So they require a limited bandwidth. So I want to send these traffic via ISP2, but 10.2, 10.3, they want to upload a big file. So I want to send this traffic via ISP1. Clear my point?
Yes.
Into this design, we are using source-based method. Source-based. Okay, router is checking what? What is source? Only source. What is source? If source is 10.2, 10.3, they can go via ISP1. If source is 10.345, they can go via ISP2. Now
Okay.
we can go with destination base. We can go with destination base, for example. Destination base means what? Wait. Destination base means now this router will don't care about source. Which source is coming? Which source is coming? This router don't care about source. Which source is coming? But if source trying to access, for example, on outside, there is a destination 99.99.99.10.11. If any source IP trying to access these two destinations, when traffic will hit on router device, then router can take a decision based on your destination based policy based routing. Okay.
Okay.
Here we can configure if any source, if they are trying to access particular destination, then router will check what? Source and destination information. And based on information, traffic is traveling via ISP1. And now if any source trying to access these two destinations, 99.99.99 and dot 100. So if destination is this, they can go via ISP2. Clear this point?
This one, yeah, yeah, is clear.
Here,
But this
here router is
decision,
not checking source
we
IP. Router is checking what? What is destination IP? What destination IP you are trying to access?
okay.
Okay.
But one question: if
Mm-hmm.
this destination is accessible via those two ISP, we can go even for ISP one and ISP two.
Your router will
What the
take a
router
decision.
will,
Your router will take a decision. On router,
okay, it
you
will
can
take
configure
decision
on router.
based on,
Let me tell
okay,
you, a router on router, you will configure policy-based routing. Router can take
okay,
a router can take a decision. A router can take a
oh,
decision based on your route map configuration, based on your policy-based routing configuration.
okay,
When traffic will hit on router, router can verify, okay, source is any, but destination is 99.99.99.10. Okay, you can go via ISP1. If source is
okay,
any,
okay,
router can verify, okay, you want to access this destination, 99.99.99.100. Okay, you can go via ISP2. This router can
okay,
take a decision. Clear this point?
yes, okay, the
So
PBR,
now we can go with source based. We can go with destination based, policy based routing, destination based. Now, our next option, our next option is what? Our next option is services
service based,
based. Services based. What is services based? So this time router will not check source IP, destination IP. No, router will check particular service. Particular service. For example,
okay,
if any source, any destination, they are trying to access FTP service, file transfer protocol. It means they are trying to upload or download file. So they can this traffic will go via ISP1. Or if any source trying to access any hello Juvency, can you hear me dear?
yes, hello,
Juvency, can you hear me dear?
yes, I can hear you
Okay,
now.
okay, okay. Now let's continue our discussion. So my point is what next option we have is services based. Router will not care about uh, source IP and destination IP. Router will care about services. What service you are trying to access. Okay, if any source,
Okay,
my point is any source IP trying to access any destination IP,
mhm,
if they are trying to access FTP service, it means they are trying to upload and download file, trying to upload and download file. So this traffic will go via ISP1. And in case if any source or any destination, they are trying to access any other service, for example, telnet service. So this traffic will go via ISP2. Clear my point? So router can take a decision based on
okay,
services.
service,
Okay. The next one is what? Packet size. Packet size. Here we can go with packet size. Packet size. Wait. Packet size. Packet size means what? If any source trying to access any destination, but if packet size, for example, in between 1000 to 2000, then traffic will go via ISP. And
oh,
if packet size what? 500 to 800, the packet will go via ISP.
it,
So
okay,
for these options, we can use PBR. These topics are called PBR, policy based routing, QNC.
okay,
Same concept you can implement in Palo Alto firewall. In Palo Alto, we can say PBF, policy based forwarding. In router, we can say policy based
yeah,
routing. In case if
that,
you are working with Fortinet firewall, In Fortinet firewall,
Oh,
you can say policy route UNC.
okay.
So it's a common concept. It's an important topic and common concept you can get in any vendor. Let's create a design. Okay, let's create a design for our implementation. So wait. So this is my first ISP connection. First ISP connection, and I have one more ISP connection. Second ISP connection I'm connecting with. Let me add a port for it.
It's
So
for
this
internet.
yes, just UNC.
Yeah, I was asking for internet why you didn't put two router.
Because I need two ISP connections. So this one is my primary connection. Either you can add two separate routers, no problem, UNC, okay?
Yeah.
But I'm using single router. You can do this. What I'm doing, this connection I'm using as a primary, okay? Primary 10 dot 1 dot 23 dot 0. And second cable is my secondary route. Secondary route 10 dot 1 dot 32 dot 0 slash 24. So I have two separate connection. And on R3 side, I'm creating some loop back for practice. So 3 dot 3 dot 1 dot 1, 2 dot 1, 3 dot 1 slash 24, 192, 168, 30 dot 1 slash 24. Now let's create some loop back here on R1. So 1 dot 1 dot 0 dot 1, 1 dot 1 dot 1 dot 1, 2 dot 1, 3 dot 1 slash 24, 192, 168, 10 dot 0 slash 20. Now let's configure IP address first. I'm trying to create this design first UNC. For basic connectivity, I'm using EIGRP protocol. Okay, UNC.
Yes.
For basic connectivity, you can use any dynamic routing protocol, no problem. Okay, let's just start our configuration. So R1 fast Ethernet 0 slash 0. And this side I'm using 10 dot 1 dot 12 dot 0 input. So this portion, my point is this portion is our LAN side portion. LAN side portion. And R2 is my public facing router. On R2, we have two separate ISP connection. Now let's start our configuration 10 dot 1 dot 12 dot 1 mask. No shut down. We can create some loopback interface. Interface loopback 1.1.0.1 mask. Back 1, 2, 3, 4, and 5. 1.1.0.1, 1.1, 2.1, 3.1, 192, 168, 10.1. You can copy and we can paste on R1. I'm using EIGRT protocol for complete connectivity, reachability 10.1.12.0, 1.1.0.0, wildcard mask, network 192.168, 10.0, wildcard mask, no auto somewhere. Let's move on R2. R2 is a public facing router, and here we have LAN portion. So fast Ethernet 0/0. We are using as a LAN portion router, LAN portion interface. So 10.1.12.2 mask, no shutdown. And interface fast Ethernet 0/1, 10.1.23.1 mask, no shutdown. Fast Ethernet 1/0. 10.1.32.1 mask, no shutdown, show IP interface brief. Router ARGRP 10.1.12.0, 10.1.23.0 wildcard mask, 10.1.32.0 wildcard mask, no auto send. Let's move on R3 router. Fast Ethernet 0/1, 10.1.23.2 mask, no shutdown, 1/0, 10.1.32.2 mask, no shutdown. Let's create some loopback interface here. So 1.1.
Replace 1 by 3.
Yes, yes. Any question?
No, no, I say here you just replace 1 by 3. Mm. No, no, you have two similar IP.
You can see any question here?
I say, please go back to your notepad.
Notepad.
Yeah, you have two similar IP. Ah, no, no, it's different. .1.1.
Thank you so much. Copy. We can paste. Router AIGRP 10, 10.1.23.0 wildcard mask, 10.1.32.0 wildcard mask. And yes, we have some loopback 192, 168, 30.0 wildcard mask, no auto something. Now we have complete configuration. We have complete reachability, show IP route EIGRP. So we have routes. You can see now to reach this,
From R2.
wait, 3.3.3, this route is installed into the routing table. You will see.
Okay.
Only this route,
Yes.
okay? Because this side we have different interface, so bandwidth is high. That's why this route is, but this, so let's wait. My point is what? Right now, traffic is traveling. But if you check on R2, show IP, EIGRP topology, to reach 3.3 network, you have two routes, right? Via 10.1.23.2, via 10.1.32.2.
Okay.
Two routes are available, but via this side you have least least FT
Okay.
value. That's why
Yeah.
this route is stored into the routing table. But you have two routes, right? You are utilizing as per routing table, you go 3.3.3, you can go via only 10.1.32. Right? You can
Okay.
see.
Yes. Yeah.
Now, let's go to R1 and I'm trying to verify my connectivity, my reachability with 3.3.1.1.1 with source 1.1.1.1. Communication is there, right?
Okay. Okay.
From R1 to R3, reachability is there. Now let's focus on our first implementation, source base. Source base. So what is our task? Our task is if 1.1.0.1 and 1.1.1 network, if these two networks they are trying to access any destination, they can go via 10.1.32 dot network, 32 dot. They can go via this side. Clear my point?
Yes.
But in case if these two network 1.1.2.1, 2 dot network, 1.1.3 dot network, if they are trying to access any destination, they can go via 23 dot. And what about REST traffic? So what is REST traffic? 192.168.10.0. This is REST traffic, right? You can see
Yeah. Yes.
REST traffic, they can go via with default feature. What is default feature? Default is what?
Primary.
Default is
Primary.
default is 10.1.32 dot. This route is the best route, right?
Yes.
Right now, as per routing table, this route is the best route. Then
Mm.
all the traffic will go via this route. Yes or no, QNC?
Yes. Yes. I get
And
your point.
and and 10.1.23 23 network, I cannot utilize right now. It is available. This network is available, but only in topology table, right?
Oh,
In routing table,
okay.
what we have in routing table only best route. In routing table,
Okay.
I have only best route. So my point is, what is my task? In my routing table, I have only best, but I want to utilize both ISP connection. This one is my primary route. This one, for example, is my primary route. You can see. You can say it's a
Okay.
primary route, and this one is my secondary route. So all the traffic, see, as per my task, if 1.1.0.1 and 1.1 network, these two networks trying to access any destination, they can go via 10.1.32.2 via this side. And if these two networks, if they are trying to access any destination, they can go via 10.1.23.2. This route is not available in routing table. Clear my point, QNC?
Yeah.
But I want to utilize both the routes. And what about remaining traffic? This is our remaining traffic. 192,
Uh,
168, 10.0 network. If 10.0
and
network,
that's
if they
way
are trying to access any destination, they can go with default behavior. What is
default.
default behavior?
Yeah.
To reach
Primary.
to reach 30 dot network, you can go via
32.
default
32.
behavior. This is default, right?
Default. Yes.
Now, for this, we can go with a route map for PBR, policy-based routing. So let's just start our configuration route map. So I'm
Okay.
creating access list first. So access list 10. 10 means what? I'm trying to configure a standard access list. You can see.
Yes.
I'm trying to
Yes. I
match
remember.
only source IP. I don't care about destination. I want to match only source IP. So
Society.
access list 10, permit, permit 1.1.0.0, wildcard mask, one more entry, 1.1.1.0 and wildcard mask. So in access list 10, I have two network information, 1.1.0.0, 1.1.1.0. Clear my point?
Yes.
Now, access list 11, permit 1.1.2.0, wildcard mask,
Mm.
1.1.3.0, wildcard. So we have two ACL entry. And now again, like last session, I'm using route map command. Yes, for PBR, policy-based routing, in Cisco router, we can use route map concept. What is command syntax? Route map. Remember? Route map, we can take a name for this route map. For example, CCIE, format. Then sequence we can take. I'm creating my first route. Here I can tell, please match IP address. It's the command.
Mm.
Please match IP address. If you type question mark, you need to define your access list number. So I'm saying please match. Wait, I'm saying please match 10. Please match 10. And if 10 match, then set IP next home. What is command? Set IP next home.
Next one.
10 dot
Okay.
1 dot 32 dot. Now
Okay.
exit. I'm creating next route map. CCIE format 2. Please match
Two.
IP address. What? What? You can see 11. Please match 11.
Even access.
And when 11 match, then set IP next home 10 dot 1 dot 23 dot
Okay.
exit. And for rest traffic, for remaining traffic, route map, CCIE format, sequence number 3. And no need to define anything. This is for
Mm.
remaining traffic.
Okay.
Remaining traffic, they will work as a default behavior. So
Mm.
route map, once you configure your route map, you need to apply on interface. So let's go to interface. On which interface? On this LAN facing interface, because all the traffic will
Passing.
hit on this LAN interface. So
Yeah.
we can go on fast Ethernet 0/0. What is command? IP policy
Okay.
route map. And what is route
Route
map
map.
name? What is route map name?
CCIE.
You can press enter, and now you are getting a message here. When you press enter, you can get a message. This is, we applied. Exit. See, we applied the configuration. Now, how to verify? How we can verify traffic is traveling through 10.1.32.2 or traveling through 10.1.23.2? How we can verify the background process? So we can use a command, debug IP policy. We can use debug command I want to verify background process on foreground. UNC, okay?
Yeah. Yeah.
Background process I want to verify on foreground. So debug IP policy is a command. With this command, I want to debug the information. What happening in background? So let's initiate our traffic. Let's go to R1. Let's go to R, and I'm trying to initiate my traffic. UNC, okay?
Mm. Yeah.
So what I'm doing, I'm trying to ping any destination, 3.3.2.1. But if source is 1.1.0.1, if source is 1.1.0.1, as per our
Mm.
task, you can see we are getting a background process message. Wait, let's initiate our traffic again. So you are getting a background message. This source,
Mm.
this source is trying to communicate with this destination, right?
Yeah.
Now FIB policy match, forwarding information base, FIB policy match. And what is gateway? 10
32.
dot 1 dot 32 dot.
Yeah,
What is
but
gateway? Now, in case destination is same, but if source is 1 dot 1 dot 2 dot 1,
mm,
1 dot 1 dot 2 dot 1. So
mm,
let's initiate our traffic. So you can see now you are getting a message. What? This source is trying to communicate this destination FIB policy match. And what is gateway? QNC?
oh, 23. Secondary
Yes. Clear now?
network. Yes.
And what about remaining traffic? What about remaining traffic? This is what our remaining traffic, right?
Mm,
It will work as a default. So let's go with default traffic. So destination is same, but now source is 192.168, 10 dot. So we are getting a message. We are getting a message. What? This source is trying to communicate with this destination. FIB policy match? No, FIB policy.
reject.
And what happened? What happened? What
Normal
happened?
forwarding.
Normal forwarding.
Mm,
This traffic is traveling through default behavior. Clear? Clear my point?
yes. Yeah.
This is what policy-based routing source base. Source base.
Mm,
We can go with destination base, no problem. Wait. Let's talk about destination base. So I'm trying to delete route map. I'm trying to delete route map. You can verify no route map is available. Show run pipe. Wait. Show run pipe section route map. You can see right now there is no route map configuration. No route map configuration. Now, now you can check access list. Yes, we have access list. So I need to delete access list. Yes, let me delete. Okay. No access list 10. No access list 11. So now we don't have access list. Do you see clear this point? Let's talk
yes.
about
Yes.
destination base. Let's talk about destination base. So this time I'm trying to match source and destination. So let's go to R2, and to match source and destination, we need to go with extended access list. Remember ACL
Mm,
standard we are using to match only source network, right? Source network, source IP, source subnet. But to match source IP, destination IP, we need to configure extended access list, right? You can see.
yes.
So for extended, I'm using a number access list 100. For extended, you can select a number in between 100 to 199. So what I'm using 100. Now question mark, format. Now question mark, IP packet, any internet protocol, any services, IP, question mark, source. So what is source? Source is any. Source is any.
Okay.
But destination, but if destination is 3 dot 3
IP
dot
address.
0 dot 0 wildcard mask. Done. First entry. And if destination is what? 3 dot 3 dot 1 dot. Now task is changed. Now task is what? If any source trying to communicate with 3 dot 3 dot 0 dot 0, 3 dot 3 dot 1 dot 0, they can go via 10 dot 1 dot 32.2. And if any source trying to communicate with this destination 3.3.2.0, 3.0, they can go via 10.1.23.2. And what about rest traffic? Rest destination is 30.0. They can go via as a default behavior. Default behavior. Clear now? Chivensy?
Yes.
This is
Yeah.
our task. Let's go to R2. This is my first access list. Into this access list, we have source any. but destination is 3.3.0.0, 1.0. Now, access list 101. 101 permit IP any source trying to communicate with 3.3.2.0 wildcard mask 3.3.3.0 wildcard mask. So we have two access list. Let's configure route map
Okay.
again. So route map CCIE format sequence number one. Please match IP address what? 100 and then set IP next hope what? 10.1.32.
Set it, uh,
Exit route map CCIE format sequence number two. Please match IP address what? 101. And if 101 match, then set IP next hope 10.1.23.2. Exit route map CCIE format 3. This is for this entry is for default behavior.
default, yeah.
Exit. Now now we can apply this interface. I think it is already applied. Okay. Uh, haven't deleted this policy map command. Wait, it is already applied. Yes, it is applied. So now let's verify debug IP policy command we can use, and we can try to initiate our traffic from R1. So what I'm doing now,
Uh,
ping, now ping source is
only this,
3.3.1. Sorry,
only
destination is what
destination.
3.3.0.1 and source is anyone 1.1
Any.
dot 1 dot 1.
Okay.
You can see message here. FIB policy match and gateway is what?
Okay. 32, yeah.
Now, if any source, if same source is same, but destination is 3.3.2.1, 2.1. Gateway is what? 23 dot. And what about REST traffic? Source is same, but destination is what? 192.168.30.1. We are we are getting a message. FIB policy match, FIB policy rejected. What happened?
Normal forwarding,
Normal
yeah.
forwarding. This is what our source base and destination base policy based routing. I hope it's clear.
Yeah, that's clear.
Now, services base and packet size we can discuss tomorrow, UNC. Okay.
No problem.
These two topics will take time, so we can discuss these two concepts tomorrow. Okay.
Okay.
Please
Okay.
connect
Thank you.
tomorrow same time. Okay. Bye, dear. Take care.
Okay. Thank you.
Bye, bye, dear.
Yeah.